Go. Triggering inflammatory response in tuberculosis. Inflammatory response, a fundamental type of response by the body to disease and injury. A response characterized by the classical signs of pain, heat, localized wound, redness, and swelling. Inflammatory response is a acute inflammation is short-lived, lasting only a few days. If it lasts longer, it's referred as a chronic inflammation, which may last weeks, months, or beyond. Here's we're going to see the first video.
Important non-specific defense against tissue damage. It begins when injured tissue cells release chemical signals that activate the endothelial cells of nearby capillaries. Within the capillaries, adhesion molecules called selectins are displayed on the activated endothelial cells. These adhesion molecules attract neutrophils, slow them down, and cause the neutrophils to roll along the endothelium. As the neutrophils roll along the endothelium, they encounter chemicals that activate integrins, which are adhesion receptors on their surfaces. These integrins then tightly attach to adhesion receptor molecules on the endothelial cells. This causes the neutrophils to stick to the endothelium and stop rolling. This accumulation of neutrophils along the walls of the capillary is referred to as margination. The inflammatory mediators released by the injured tissue bring about changes in the environment that cause mast cells to.
Okay, Next, we're gonna talk about tuberculosis. In the past, also called phthisis pulmonalis or consumption, is infection disease caused by various strains of mycobacterium, usually Mycobacterium tuberculosis. Tuberculosis. Tuberculosis typically attacks the lungs but can also affect other parts of the body. It spreads through the air when people who have an active TB infection cough through contaminated body fluids such as saliva or water droplets. Here we're gonna see another video about the truth about TB. A cough for 3 weeks, loss of appetite, tiredness, fever, weight loss, loss of weight, night sweats. These are the classical signs for tuberculosis. Okay, we're gonna see next. Inflammation in tuberculosis. Infection with Mycobacterium tuberculosis is accompanied by an intense and local inflammation response which may be critical. Activation of components of the innate immune response such as recruitment of PMN and mononuclear phagocytes trigger the inflammatory response. Targeting the inflammatory response in TB. Major Barber and colleagues recently observed increased bacterial loss of Mycobacterium tuberculosis, which include primarily E2 and leukotriene. Using COX-2 inhibitors, the investigators were able to block interleukin-1 dependent control of Mycobacterium infection in macrophages, and then restore it with PGE2, prostaglandin E2. Okay, here's the final video, killer disease.
An estimated 1/3 of the world's population is infected with tuberculosis. 1/3. And here's the culprit, the minuscule bacterium called Mycobacterium tuberculosis. But does that mean 2.3 billion people are sick? Fortunately not. Only a small proportion of them actually become sick. To understand why, let's take a closer look at the bacterium itself. When someone with TB coughs, they expel little drops of saliva that fly into the air. Some of them may contain the TB mycobacteria, which can then be inhaled by someone close by. The mycobacteria then continue their journey down the respiratory tract and into the lungs. That person is then infected with TB. And this is where it all becomes a little more complicated. The body detects the invasion and sends out its first line of defense. This includes special cells called macrophages, which engulf the mycobacteria and transport them to the lymph nodes, where they are neutralized. If they're neutralized, the person will have what is called latent tuberculosis. This means they're infected with the bacterium, but they don't have active TB disease, and they're not sick. However, in 5% of cases, the immune system is overwhelmed. The TB mycobacteria multiply and escape, and the person falls ill. This often happens with young children, whose immune systems are not fully developed. In other cases, latent TB can wake up and become active TB. This can happen months later, or even years later, especially in adults with weak immune systems. For example, people who are HIV positive, or who've had organ transplants.
Okay, that's enough. Thank you.